Greetings, Dr. Renner. Today I'll be explaining my information retrieval project. For question 1, this task involves designing a program that can read and extract text from files stored in a directory. When executed, the program first scans the directory and displays a list of available PDF files. Each file is assigned a number, and the user is prompted to enter the corresponding number to select a file for reading. Once a file is selected, the program extracts and displays its text content. Here I prompt 4. It will extract and display the content of P4. It's about blockchain technology. For question 2, read all the text files given in the directory and construct the TF-IDF for the sample collection after removing all stock words and performing the stemming process. The first step in our process is pre-processing the text documents. This involves removing stock words and applying stemming. Once the text has been cleaned and processed, we move to TF-IDF computation. TF-IDF, or Term Frequency Inverse Document Frequency, is a statistical measure that evaluates the importance of words in a document relative to the entire collection. Words that appear frequently in a single document but are rare across others get a higher score, indicating their significance in distinguishing the document content. In the output, we see the pre-processed version of all the 10 documents, where unnecessary words have been removed. Below that, we see the TF-IDF matrix, which lists important terms along with their scores. For instance, the term accuracy has a TF-IDF score of 0.0565, indicating its relative importance in the document. Question 3 focuses on ranking text files based on a given query. The objective of this task is to determine which documents are most relevant to a user's query and arrange them in order of relevance. To achieve this, we use TF-IDF and cosine similarity. Once the TF-IDF values are calculated for all documents, we apply cosine similarity, which compares the TF-IDF vectors for the TF-IDF vectors of the documents to the query. This results in a similarity score for each document, which allows us to rank them from most to least relevant. For example, when given the query digital twin is related to generative AI, the system generates the following ranked list of documents along with their similarity scores. The higher the cosine similarity score, the more relevant the document is to the query. In this example, P8PDF and P1PDF have the highest scores, meaning they contain the most relevant content related to digital twin and generative AI. On the other hand, P3PDF and P6PDF have a similarity score of 0.0000, indicating that they do not contain meaningful information related to the query. Question 4 involves computing frequent term sets from a given query based on a user-defined frequency result. This task helps identify the most commonly occurring terms in a dataset and determine in which documents these terms appear. To perform this, the system first takes a query with at least 5 words as input. Then the user sets a frequency result, which defines the minimum number of documents in which a term must appear to be considered frequent. The program processes all documents, extracts words from them, and counts their occurrences. Finally, it identifies and displays frequent term sets, along with the documents they appear in. For example, given the query, digital twin is related to generative AI, and a frequency result of 3, the system produces the following results. In this output, the term AI appears in all 10 documents, making it the most common term. Meanwhile, digital is found in 4 documents. These frequent terms help identify which words are most relevant across multiple documents. Question 5 requires us to compute the precision at any position k based on a query Ranked document results from question tree and a list of relevant documents. To generate the document ranking, our system uses TF, IDF, and cosine similarity. The documents are then ranked in descending order based on their similarity scores, with higher scoring documents appearing first. After this ranking is produced, the user provides a list of relevant documents. We then compute precision at K, which helps determine how many of the top K retrieved documents are actually relevant. For example, when given the query, digital twin is related to generative AI, the system ranks the documents as follows: P at PDF with a score of 0.4710, P1 PDF 0.3716, P10 PDF 0.0562, and so on. The user identifies P1 and P at PDF as relevant documents. For precision at K1, the top-ranked document P at PDF is not relevant, so precision at 1 equal to 0.0000. At K2, one out of the two top-ranked documents, P at PDF and P1 PDF is relevant, making precision at 2 is equal to 0.5000. At K3, only one relevant document appears in the top 3, P at and P1 and P10, resulting in precision at 3 is 0.3333.